again, looking at it, the first thing I noticed about the problem is there's what's called a GCF in the problem. And you could do the GCF. Another thing I noticed, there's four terms. And you know what I'm gonna do? I'm gonna factor it by grouping. All right. I'm not saying it's gonna work, but I'm looking at it and I'm thinking to myself, if I could divide this into two separate problems, maybe things are gonna work out for me. So let's take a look at it. Now the first two terms here have a common factor, and that common factor is 6x5. By the way, if this is a dead end, erase it and try something different. And what do you get over there? Well, you would get 2x minus 3. Next up, minus. Well, what's common between 6 and 9? That would be 3. And then what's the biggest factor? Xy's would be x cubed. Again, this could be a dead end. What do you get now? 2x minus 3. It's not a dead end. So let's write this down. There's a common factor between these two terms. And what is it? Well, I'm looking at it. It's 3. That's common. X cubed. That's common. And 2x minus 3. That's common. What remains? 2x squared minus 1. All right? So I want to be honest with you. Certainly someone says, could you factor the 2x squared minus 1? Of course you can. But it's going to involve numbers that are a little bit tricky at this stage of the game. But this here is actually a difference of perfect squares. You just may not recognize it at this point. So I'm going to say here, this is a good place to stop at this point in your career. We're at page 288. Later on, we'll be talking about how to factor that as well. But anyway, what do you have here? 3x cubed, I see that. 2x minus 3, I see that. And then the 2x squared minus 1, I see that. And we're done. We move on. Thank you.